So we're looking at the addition and subtraction of surds, and it's important that you remember that surds can only be added and subtracted if they are like surds. Now, when we say like surds, it's kind of like terms. Like a plus a can be added to make 2a. So where we have x plus y, these are not like terms. So x plus y simply equals x plus y. We can't simplify it in any way because x and y are different terms. However, if we have something like 3x plus 7x, these two are said to be like terms. They're both x's. So 3 plus 7x is the same as 10x. Now surds works the same way. So if we have something like 2 root 3 plus 5 root 3, we can simply add them to get 7 root 3, as if it were an x and an x, and 2x plus 5x would be 7x. Now the reason this works is to do with the distributive law in essence. What we can do when we have the 2 root 3 and the 5 root 3 is that we can factor out the root 3. Just like you can take out or factorize out a letter or pronumeral, you can factorize out the root 3. And then our brackets become some simple maths, 2 plus 5, and we end up with the 7, and we remember that we should always put the number first and then our square root. Now, sometimes you'll come across surds that look like they're different terms and nothing can be done. For example, root 2 plus root 18 can't really be added because they're not like. They don't both end in the same square root, so to speak. But what you need to do is you need to take a close look at them and see if you can't simplify one. Like in this instance, root 18 can be simplified to root 9 times root 2, remembering our multiplication rules. So the square root of 9 then is 3. So the maths that we end up with is root 2 plus 3 root 2. We can factorize out the root 2 and we would end up with 1 plus 3, in which case our answer would be 4 root 2. Now, like any maths, you can put this into your calculator and you can put this into your calculator and you can check to make sure that you get the same answer, and then you know that you've done the maths right. Okay, let's look at some examples then. So the first one, we can see that we have all like terms. It's root 5, root 5, root 5, and root 5. So it's as simple as taking the root 5 out and looking at the maths which is left behind. So we've got 7 minus 13 plus 4 and minus 1. So if we do this maths, we end up with negative 3 and root 5. All you need to do, put this in your calculator, put this in your calculator, and you'll see that they're exactly the same. So for the next one, we can see that we have two different like terms. We've got a root 6, the root 6, and a root 3 and a root 3. Now we can just rewrite this so that the terms are together. So 10 root 6, and it's minus 5 root 6. And we've got our plus 3 root 3 and minus 8 root 3. So our like terms, we've got 10 minus 5 would leave us with 5 root 6. And we've got plus 3 minus 8 would be negative 5. So instead of plus, it'd be minus 5 root 3. Again, put it in your calculator, give it a check, see if you got it right. And in the last one here, it looks like we can't do anything because they don't look like terms. Again, what you need to do is look for the simplified version of this term. So we're taking out a perfect square. 63 can be divided by 9, so it's going to be the same as 5 times root 9 times root 7. So 9 times 7 being 63. And the root 9 is 3, and 5 times 3 is 15 root 7. And then our 28 is also the same as 4 times root 7, the square root of 4 being 2, 2 times 7 being 14, and 15 minus 14 is being 1, so the answer is simply root 7. Again, put it all in the calculator, check that you got it right.